everybody. Welcome to the Web3 Business podcast brought to you by Tokenmize. I'm joined here as usual by my colleagues Edgar and Kay. Hello, welcome guys.
Hi everyone.
Hi everyone.
And of course, my name is Rob, and I have today a special guest, David, a returning guest from Satya. Welcome, David.
Thanks, Rob. Edgar, Kay.
Yeah, as this is kind of the part 2 episode of this podcast, let's just dive right into it. Edgar, do you want to kick things off?
Sure. So, just this morning I've been preparing some questions here. I have been discussing it with Kay. So we actually dived into the Red Square, the social media for Saito.
Mhm.
I was just curious. Is every post in Red Square is it considered a transaction?
Okay, so my understanding is the question is every tweet a transaction? And the answer is yes. When you make a tweet, you put it in a transaction. The reason you do that is that when a transaction arrives at another node, we validate it. Is this from you? Is it from the public key? And if the transaction is invalid, the signature is invalid, you don't process the tweet. That doesn't mean the transaction needs to go on-chain. So when you're designing these applications, you have the choice of saying, I'm only going to process the transactions that are on-chain. I'm only going to process the transactions that are off-chain. I'm going to process both types. And it depends on the type of application. So for something like Red Square, there's one mechanism. Early on, we're publishing everything to the chain. Anyone can just sync the chain and they're going to have the same content. So you could have 2 servers with different moderation policies processing Twitter. However, you can also shift to this swarm model, which is what we're developing towards, which is that you guys are my friends. And so when I connect, I go and I check your archives. And those archives are going to have on-chain tweets, but they might also have off-chain tweets. And so you can combine them. And it basically depends. The blockchain needs to scale with what the on-chain transaction volume needs, and it supports the Swarm ecosystem. So it's a combination of the two. But the short answer is yes, everything needs to be in a transaction because that's the language the system understands. And it's the language the system validates, right? Like, we can't have Robbie pretending to be you and publishing tweets. But the choice of whether you put those transactions on chain or if you send them off chain to your peers and how you do that is not something that's limited by the blockchain. And Red Square is designed for both.
Okay. Thank you. You mean what you mentioned that every tweet is a transaction, right? So if it's a transaction, then who pays for the validators for the transaction fee?
Well, there's no validators in Saito. So we're not in a proof of stake ecosystem. And the question I throw back at you is people think proof of stake works. The servers that are doing the data processing for an application like Red Square it's essentially Infura. It's not the validators. So right away, you've got an economic problem with proof of work and proof of stake in that the computers that are needed to support these kind of applications aren't the ones that are getting the fee. What we technically have is we have a form of free riding where there's a very narrow range of technical activities that if you do this work, you'll get paid, and that's validation. And then there's this broader range of stuff running in Infura servers, running this peer-to-peer architecture, any data services that are connecting people, the application developers, that's unpaid. So the first answer to your question is pointing out that to the extent you're describing a problem, you're describing a problem with proof of stake that people don't talk about. The second question is, okay, we've got a Red Square mechanism. We've got transactions. Where do fees come in? Well, if you want to broadcast your transaction on chain, you're going to need to pay a fee. So right away, we have a reason why for some users, on-chain and off-chain is different. If I'm doing casual tweeting and I'm Julian Assange, I probably want to be spending the fee to broadcast on-chain because there's guarantees of data distribution. Everyone will get this. There's guarantees that the blockchain will save that data that don't exist if I just make a fee-free transaction and post it to a private transaction archive. But from the perspective of building global swarm applications, we can't build a global swarm application that's going to broadcast everything on chain. So we need an application structure that grows organically with scale. We can talk about this if you want, but I think most people, when most people think about scalability issues, it's a scalability discussion, not who pays a transaction fee. The transaction fee question, all you need is a business model that goes to a purpose, and there's any combination of them. For instance, in Gmail, they give you 2 gigabytes of data if you use their Gmail service. So there's a business model there, and it collects money, and they use that to subsidize this thing that gets you using them. With routing work mechanisms like Cyto, it's the same thing. If I'm connecting to you and I'm sending my on-chain transactions through you, you're getting a portion of that fee. So we are expecting that the nodes that service the on-chain transactions will also do things like say, well, if you're giving me $20 a month in transaction fees, I'm going to give you this off-chain transaction archive. And you can tell your friends to come and get your tweets from our off-chain transaction archive because there's a business model for it. And the difference here between proof of stake and routing work is in proof of stake, that business model is totally disconnected from the fee. With routing work, we're paying for the stuff the applications need out of the transaction fee because the people that are providing the network, they get paid out of moving transactions around. So it's a paradigm shift, but it goes right back to your question, which is, who's paying for this stuff? And more importantly, are the people that are spending the money the ones that are making the money? And if we're giving all of the money to the validators, the answer is no. And if we're giving all of the money to the miners, the answer is no. But very few people think about this as a problem because we're all, proof of work and proof of stake people. They argue against each other and they've got the same problems.
Okay. Thank you for that, David. Also, I have another question. Does Saito also have an Explorer, same as the Etherscan, where you can view the transactions?
We've got one. We use it mostly for dev. It's saito.io/explorer. So you can see the blocks that are circulating. You can look inside and see what's in the transactions if you want, unless they're encrypted, because you can do that. You can the application data you publish, it goes in a transaction, and that data can be encrypted. So we can play a game of chess, Twilight Struggle, and we can encrypt the transactions and decrypt them on our ends, and only we can see what we're doing. The blockchain just sees that there's a transaction that happened with a message we can't read.
Thank you. Also, I've been checking on the developer docs of Saito. Does Saito also have a development community, same as the stock exchange, where developers can ask questions, post some questions for other developers to answer?
We've got active developers. I mean, we're a small chain in the scheme of things. We've got community developers, people who are building who aren't on team. We've got community developed applications. We don't have like a formal system of how a third party should interact with us. Anyone who wants to dev, they can hit me up. They can hit Muck up, they can hit Richard up. There's a bunch of independent devs doing work. What basically happens is people come and they say, I've got this idea. And we say, well, are you willing to do any work coding it? And if the answer is no, it usually doesn't happen unless it's a really good idea. But if the answer is yes, it's like, okay, let's get you started. And usually that involves us helping learn how to do it. For instance, if someone wants to develop a game, we'll say, okay, here's a starting point for an application. We've got docs, but I don't think someone is going to work just from the docs and go 0 to hero, right? Yeah.
If I want to build in Saito, where should I start? Who should
Start by coming to Saito Telegram and say, hey, I want to do this. And Share what the idea is, because until people say what the idea is, it's hard to know how to get people started, right? Like, some of the easiest things to do are, we've got all of these applications. Maybe you just want to tweak one. Maybe you just want to improve red square. Or maybe there's a game and you want to modify that. The logic for the games, how the games are coded, there's a separate protocol. So if you're building an application like Trustless Poker, there's a game library that takes care of everything that's computationally difficult. And games can work the same as complicated industrial scale applications, because what a game is doing is, it means people broadcast moves, and those moves need to be executed in the same order on all of the machines. So there's a logic for how to do that that's very simple on Cyto that works for other applications. But that's not the same as Twitter, right? Like, if we're doing red square, it doesn't really matter what order the tweets arrive in. So the application development, again, it can be flexible. Is it on-chain, off-chain? So we encourage people to hit us up on Cyto Teaching. We're going to have revamped docs later this summer, but I think anyone who's serious about developing, get in touch with us personally. And we can get them in touch either with core team members or members of the community who are already building and already know all of the answers that they're going to run into.
Yeah. All the applications built on Cyto is it everything open source that you can scan through?
Yeah, if you go to GitHub, Cyto Tech, Cyto Light Rust, there's a mods directory, and inside that mods directory, all of the files, the folders you'll see, are separate applications. Some of them are like Red Square. Some of them are, okay, there's a big UI and it's complicated, you can click and it's got UI components. Others, like the encrypt module. The encrypt module is beautiful. All that does is it manages something called the Diffie-Hellman key exchange process. So that's us using the blockchain to create a shared secret. It's a module that does that. So if someone wants to upgrade the security of their encryption or use a different encryption algorithm, it's very easy for them to do that. And then basically, when you use it in your browser, when you're running Cyto, you're running the core client with whatever modules you decide to install. So it's kind of like a Bitcoin wallet where you install applications.
Yeah. Okay. One other thing, we also tried this morning the video call for Insight. So,
sorry, which one?
The video call.
Video
we
call.
tried it. Yeah, I tried it with Kay, and I was surprised that the connection was real clear. And does it work? The video call works behind. Is it everything on chain, or it's part web?
Look at what's happening here. Okay, so this is a really good example of why and how we want to mix on-chain and off-chain. The blockchain is used to initiate a connection because you got your public key and Kay's got her public key. But any method you guys have of connecting, there's going to be a man-in-the-middle attack. But because you've got the public keys, you can fall back to using the blockchain to punch through any NAT and to punch through any middle third party. Because you're going to send Kay a transaction that says, here's my IP address. Here is, I'm listening for this. We're going to negotiate this off-chain connection so we can send a lot of binary data content, because that's the video channel, right? You want to make sure there's no one in the middle standing between you and Kay who is eavesdropping on them. And so that's what we're using the blockchain for. You're making a transaction, you get it to her, and she can validate that the signature comes from you. So the identity is the address on the network. That's what we're leveraging. And you can do this off-chain. For instance, you might connect to a server, and you connect to the server, and if Kay is connected to the same server, we don't need to use the blockchain. We can use standard NAT traversal techniques to connect you guys. You got to trust us. But if you don't trust us, or you're not connected to the same server, you can still punch through. And so that's where the blockchain comes into play. And it's why the application, we're talking about what's on chain and what's off chain. The video stuff, we don't want that stuff on chain. the costs of supporting that. I mean, it's you don't want to do it. We want to connect people. If we're playing a game of poker, it's the same thing. Now, if we're playing poker and I need to pay you in tokens, that's a transaction that needs to be on chain because we need the ledger updated. But if we want to have a video call, well, I'm connected with you, we're playing poker, let's have this off-chain data channel. And one of the beautiful things we can do with this approach is, because we're a routing mechanism, once we have that off-chain channel, I can start sending you transactions. And you can then relay transactions into the blockchain. And you're now providing the infrastructure. And because you're now providing the infrastructure, you're now getting paid for it. So I don't know if, I think everybody a lot of people are trapped by proof of stake and proof of work. They're trapped into thinking that the only applications we can run on a blockchain are DeFi, low throughput cryptoware. And then we get networks like Sol that come in that say, well, we're going to force people to buy really expensive machines and we're going to have more centralized design, and you can still run cryptoware. Routing work, we don't need to run cryptoware. The money goes to the people that are running the infrastructure, and we have the choice of on-chain and off-chain. And the network is designed for that. Whereas with other communities, we don't really see it because, like Infura is not paid to facilitate you and Kay connecting and sending video streams. But if you need an on-chain transaction to do it, that on-chain fee pays for me to facilitate that for you. So of course I'm going to do it. Like, the form of paid work stops being mining, it stops being staking. And in this instance, it turns into connecting Edgar and Kay so they can create this off-chain channel. And that's the version of Cyto that we believe will exist at massive global scale. Because at massive global scale, we're not going to have the capacity to have every tweet published on chain. But we will have the capacity to connect a global population that is creating and sustaining the Swarm community. And the application designs, all of the applications we're building are designed to gradually step up and have this off-chain transactions where needed. And so people can individually make their decisions. There's some people it'll cost $1 per tweet, they're still going to send it on chain. Other people are going to be like, well, it's like a blog. Here's my transaction archive. You want my tweets? Come here. Does that make sense?
Yeah.
I'm kind of taking your questions and answering them in a way I think might help explain Cyto better.
Yeah. Thank you, David. I think that's all for my questions.
Okay. Thank you for the questions. They're good ones.
I think you're unmuted.
Rob, you're muted.
Oh, sorry about that. Yeah, I just want to jump in quickly about one of the questions from just now, because I think in me and probably some of our listeners might not fully understand what you mean when we're talking about the routing work mechanism, right? Because Satio obviously isn't using proof of stake or proof of work for the consensus mechanism, but how does a routing work mechanism help with consensus, or is that? Can you maybe explain a little bit more about the consensus mechanism and the routing work mechanism that you're talking about?
There's so many ways to answer this. I can explain to you how it works from a technical perspective, which is I make a transaction, what happens, who gets paid. I can explain from a theoretical perspective, which is there's no 51% attacks, but why is that?
I think it will be good to explain it from a consensus mechanism, right? How is this replacing specifically the consensus mechanism that is used in proof of stake and proof of work? How does it compare, basically? How does it replace this?
I mean, the answer is it's better, but how do we talk about this? It's just such a general question. I think what you're asking. What you're saying is okay, look, I know how proof of work and I know how proof of stake work, and I think routing work has to be secure and it has to compare.
Well, it's
But
it's more from a perspective of I understand how proof of work and proof of stake can come to a consensus of the state of the blockchain. How does that work specifically for the routing work?
okay, so we're still a blockchain, and you're still going to get blocks, and the blocks have transactions inside. And the short technical explanation of routing work is that there is something new. And what's new is that the transaction have routing signatures. So let's say I'm a user and I make a transaction and I'm connected to Edgar. I send the transaction to Edgar. That transaction has a certain fee. Edgar puts it in his mempool. And Edgar now has a one-hop transaction with a certain amount of Cyto attached. You can think of that as routing work that builds up in the mempool. Now, if Edgar sends it to you, Robbie, you're going to have a two-hop transaction with the same fee, but you're going to have half as much routing work. So the transactions flow into the network, and it's kind of like, a good analogy might be Bitcoin, but instead of the miners mining a hash, the transactions contain a hash. And you add up the difficulty of the hash in the transaction. And then when you have enough hash to meet overall difficulty requirements, you produce a block.
And that goes over my head. Maybe from a little bit of different perspective. How specifically, how do you prevent double spend? Let's say maybe just the bare basics.
Let me try to get you on this, and then we can move on to this question, because I think the answer is important. In proof of work, you've got miners. They get the transactions, they mine to make a block, and when they make a block, they publish it, and they're going to get paid. They're going to collect the fees. That's the miner is doing the mining. Think of a version of proof of work where instead of the miner mining, they're given hashes by people in transactions. So when I make a transaction, I do a bunch of hashing and I generate a difficulty proof. Maybe it takes me 10 seconds of mining to get a hard enough one. When I give that to you and you've got 1,000 transactions to put in a block, you've got 1,000 transactions that have taken 10 seconds each. Add those transactions together, you can prove you've done a certain amount of mining and you can publish that. The reason this doesn't work in proof of work is because everyone has the same number, everyone has the same hashes in their transactions, right? So everyone's going to produce a block at the same time. Do you see the change and the problem it creates?
I gotta be honest, not exactly. Because what the point I'm missing here is really obviously proof of work. I understand. I'm just going bare basics here, right? You're putting in a certain amount of energy, and you're risking that if there is no consensus on the block you're producing. So you can lose that. Same with proof of stake. You can lose that stake if the consensus is not there. How is that situation in
the abstract answer is that it's like proof of work and proof of stake. There is a form of work that is costly to generate, and that form of work allows people to produce blocks. Routing work is designed so that work comes from the transactions and the transaction fee. And the first problem we have to solve is, if the work is in the transactions, why doesn't everyone produce a block at the same time? But fundamentally, theoretically, you can think of it as mining, staking, routing. You're doing different things, and generating the work costs money. And whoever, at a certain point, someone is going to be able to produce a block. And at that point, the difference is, in proof of work and proof of stake, they have to pay the miner and they have to pay the staker. And the reason for that is, if you start paying anyone else, you open up a tax on the payment mechanism. Right? Like, Bitcoin can't say, I'm going to pay a random guy in the routing network, because if they say, look, we're going to take 50% of the money and we're going to give it to a random guy in the routing network, they have no ability to prevent themselves from being cheated. Right? Like, Edgar could add a transaction, and before he sends it to you, he sends it to 15 to 20 copies of himself to increase his chance of getting paid. And so as soon as you add a payment that's not for the security function, you lower the security of the network, because you open attack vectors where people can do cheap things to get paid. This is the Sybil, it's the Sybil problem in Bitcoin and proof of stake, right? Like, why do we only pay the people that mine? We only pay the people that mine because if we pay for something else, everyone does the thing that's cheap. They don't do the thing that costs money. So the Sybil attack is when there's a way to make money and it requires you to hash or stake or whatever. But if you create a bunch of cheap identities, you now have a way of getting paid. So everyone does the cheap thing that gets paid. No one does the more expensive thing.
Right, but the Sybil attack is kind. I mean, in order to do a Sybil attack on a network like Ethereum, you need to control an amount of stake that is at least 51% of the total value of the network, which is billions of dollars.
Well, that's not true. You need to control 51% of the amount that's staked.
Right.
And stake is an
rather stake. Yeah.
No. This is important, right? Because people don't think about this. You need a 51% of the amount that's staked. There is an economic value to stake because stake is now an economic commodity, which means it's something that as the blockchain grows and as the free market is going to commoditize stake in the same way it's commoditizing hash, which means we eventually get to a point where you can rent stake at the value of its expected income. And then we're right back to the beginning of, is this secure? Because the value of stake, it breaks at the 51% point. This is, if you rent 51% of stake, you can make 70% of income. If you rent 51% of hash, you can get 100% of income. So there are these unsolved economic problems in proof of work and proof of stake. Routing work doesn't actually have them. So that's one answer to your question, but it's why it's difficult to talk about sometimes, because people think that proof of work and proof of stake are secure against attacks. They're not. What's happening is we've got money moving in a circle. We're spending money to generate work to collect the money that we're spending. And 51% of the money will always buy 100% of it if we cheat. And so the question is, well, why aren't people colluding to cheat? And the answer is that they are.
Right. I wonder, David, I might have not come this across yet, but is there let's say, some kind of a video on exactly, because you have a lot of those videos on Ethereum, DeFi protocols, that actually shows how the Satio protocol works and how the routing mechanism.
I mean, I can explain it for you technically. The problem is that the technical explanation isn't answering the question you're asking, because you're like, what is it? The question you're asking, I think, is how does consensus work? Routing work is like mining and staking. You have to spend money to generate it. And so it's like stake, it's like mine, it's costly to produce. And the difference is on the economic layer, where, for instance, like the 51% attack, in routing work, if you have 60% of the work, the routing work in the network, you can produce 60% of the blocks in the network. But if you produce more than 60%, you're going to lose money. That's not something that happens in proof of work and proof of stake. So this abstract way of talking about it, what changes? It's like proof of work, it's like proof of stake, but something changes, is very different than how it actually works. We've got a one page on our wiki. If people are interested in exactly how it works, go to wiki.cyto.io, and I believe it's /EN for English, /consensus. And we have a one page write-up that says this is exactly what happens.
Yeah, that's great. I'm looking at it right now. It will be nice, I think, if there's also some visual representation where you just walk through the process, what happens, to are there still nodes in Satio, or?
Well, I mean, let me pull up we can take it paragraph by paragraph. Yeah, it's like blockchain. First sentence, when users send transactions into the network, they send them to a node. or 2 nodes actually. So that's me making a transaction and sending it to Edgar. The difference between this and Bitcoin is in Bitcoin, there's no cryptographic signature.
And what do you need to do to actually run the nodes?
You run the software. It's like running a Bitcoin node. It's exactly the same as Bitcoin. You run the software.
But you don't have to stake anything. You just getting paid, or what is?
Well, I mean, if you're generating work, the work is coming. Maybe I'll give you the abstract. The work is coming from the transactions. It's coming from the fee that's in the transaction. So if you run a node and you don't run a web server, no one else connects to you, you're not spending bandwidth, you're not spending CPU, you're not taking blocks from someone and giving them to someone who wants to have pay a fee, you're not doing valuable work. You're not going to be able to produce a block.
Right.
Unless you spend your own money. You can do that.
The node spends their own money to.
We're not. I don't think I wouldn't. Why would you do that? You'd lose money. What we're doing is we're creating a game, a consensus mechanism, where you can make money if the work that you put in the block comes from someone else. So if you run Infura, you're running a node. You run the software, here's my web address, connect to my Sado node. If people connect with their browsers, they start using it, they start paying transaction fees, you start getting work in your mempool. Eventually you can produce a block.
So but I mean, so just for my, so some user is running one of the applications in there, then I'm guessing they would send transactions to whatever node is connected to them. They create a
this is how Bitcoin works, right? It's how proof of stake works. You run a node, and if you're making a transaction, you send it to that node.
Right.
Now, this is where most of Web3 breaks.
Exactly. I think we're on the same page there, because I think most people understand that. And then the nodes can be checked if they're truthful based on the work, the proof work of stake.
Do you have the money? The node can check if you have the fee. So the node is not going to share invalid transactions. An invalid transaction is worthless to it. So a node, if you start cheating the node says, why are you sending me garbage transactions? It'll cut you out of the network, go somewhere else. There's a significant difference here though. Look at Ethereum. One of the major ETHCC, I heard that Vitalik is there saying, hey guys, we've got to promote light clients. No one is paying for light clients. It's volunteer infrastructure that they're building, and they want Infura to support more light clients. In Sito with routing work. Now, if I'm a light client and I connect to you, you have an incentive to give me light blocks because I'm giving you fees. And it's only if I give you fees that you get paid.
Yeah, the fees are going directly from the user to the nodes, right? That's what you're saying.
No, the fees are going into the blockchain, but the blockchain is going to pay the people that have routed the fees. So this is a difference in proof of work and proof of stake. The block producer gets all the money. And the reason they do that is because we can't pay anyone else without opening up Sybil attacks and attacks on the payment mechanism. That's why people talk about the blockchain trilemma and they have Ethereum is here and Bitcoin is here. It's garbage. Proof of work and proof of stake give 100% of their fees to miners and stakers. Because if you lower that, you lower the return on investment to miners and stakers, you lower the amount of mining you get, you lower the amount of staking you get, security goes down.
Right.
Spending any money on the network, security goes down. We're trapped in the trilemma. And so they solve it with bullshit. With Sito with routing work, now the fact that I sent you the transaction and the fact that you made the block doesn't mean you get paid. This is something the cryptographic.
So how does that work? So how does the node then know that it's a truthful transaction, right? Before kind of putting it into the block.
Well, it's a UTXO system. You can check, is the UTXO valid? You basically keep a hash map of who has what UTXO and what's it worth. If someone sends you a transaction, you just say, is this input valid? Yeah, it's what people do in Bitcoin.
I understand that, but that's assuming indeed. But what if there is let's say a double spend problem, right?
We can talk about double spends. I mean, double spending is different. Bitcoin nodes and Sito nodes, there's no difference here. We're talking about collecting transactions and putting them in blocks. Right. Now, a node, that is double spending deliberately in Bitcoin, well, that node is malicious.
Sure.
Right? So it's like, okay, we're talking about attack vectors now. Or the node could just be really inefficient. The node might not know that there's another block where this has been spent. That's okay. We can talk about that. We're talking right now about how consensus works, which means we're not talking about how you attack it. Which is
I get it. Yeah.
So,
that part is not 100% clear to me.
Well, let's get to it, but we can't get to it until you see the differences, right? Do you see that in proof of work and proof of stake, if you make a block, you get paid, but other people don't get paid because we can't have a mechanism that pays other people that doesn't lower security. One of the technical things that routing work does, to answer your earlier question, why it's better, is that security is going to go up. When you produce a block, let's say you collect all these transactions, you make a block, your chance of getting paid is proportional to the amount of routing work you have in your block. That means if you just have transactions from me and you're the only guy that has those transactions, your chance of getting paid is 100%. But maybe I sent the transactions to Edgar and Edgar sent them to you. In that case, you're a second hop node, Edgar's a first hop node. When you make a block, that block has transactions that routed through Edgar. And we're going to play a costly game that decides who gets paid, you or Edgar. And some of the time you're going to get paid, and some of the time Edgar's getting paid. And in order to, if you can see this, we can then move on to, or we can move back. We can keep going on whatever direction you want, but going back to the Vitalik point, if Edgar is doing the computational work to generate the fee, he's getting paid a certain amount of the time. But Edgar can't produce blocks. He can't produce them without your help. You're doing something else. Maybe Kay is doing work and you're combining the transaction streams. So you're combining these money flows until it's important and powerful enough that you can regularly come out with these blocks.
Yeah.
So these guys are servicing me and you're servicing them. Everybody's going to get paid. You cannot do this in proof of work and proof of stake because there's no way to identify who Edgar and Kay is and pay them. If there was, Ethereum would be using it instead of begging volunteers to run light client infrastructure.
Yeah, exactly. So you solved that problem, right? But again,
that's the Sybil problem.
Right.
It's the Sybil problem because what we're allowing is we're allowing a portion of the block reward to flow to people who aren't the block producer. And the way we do this,
But how does the? I'm sorry. This in the terms of the time, right? We're always. This is again the same situation. So yeah, just. Or maybe you can point me to the right direction here and our listeners. So of course I understand you're solving the light node issue, making sure that that's covered, making the network in terms more secure. Okay, understood so far. But my question still kind of goes back to, okay, you're not using proof of work, not using proof of stake. So the final block producer, right? Like how does this link up to the fact that those blocks are secure, that they don't have any double spend, they're truthful to producing the right transactions?
Well, I mean, it's longest chain, so it's just like Bitcoin in that regard. You've got fees that are flowing into the network, and those fees are being spent to extend the chain and produce the longest block. In order to, what we tend to do is when a block is produced, all of the fees in the block are burned. Nobody gets paid. So this is another difference. Proof of stake, we've got the problem that I think you're alluding to, because in proof of stake, I can produce a block, I produce block 2, I produce block 3. Now, because it's my turn in the queue, I can produce another 3-block chain. I can costlessly produce 2 competing forks, because it's my turn. I can team up with people to produce 500 forks. This is one of the proof of stake. They don't have a solution to this. They say, we're going to socially slash people, but you can't slash a majority. So proof of stake is capped at 50%. Proof of work is capped at 50%. I think the question you're asking is, well, if we're just putting fees into blocks, why don't we have the same problem that proof of stake does? Is that the question, the costless creation of different forks?
Yeah, exactly. The double spend problem.
Okay, I'm gonna get you on, not get you on this one. I'm gonna get you here, because when we produce a block, when you make a block, you don't just put the money in your pocket. You can't, because if we let you put the money in your pocket, whatever mechanism we used, you could cheat. So what we do when we say, okay, look, you're gonna make a block, all of those fees are burned. And this is actually, it's an important development, because it means that if you're attacking the network using your own money, you've got to burn your own money to make blocks. And we start playing a statistical game where it's going to cost you this amount to make a block. How much money are you getting back? Now, if you're putting transactions that have come to you from Edgar into your blocks, and you're competing against K, let's say you and K are both hop 2 nodes. You're competing against K to be who's the first who's going to put David's transaction into their block, because the first one that does it gets paid. The second one that does it gets nothing. So you're racing with the other nodes in the network to build. If all of the nodes colluded, you could theoretically say, well, look, we've got the same fees. We're going to make 2 forks, 3 forks. We could double spend. But look, we're burning the fees when we make the block. And in order to unburn them, that's when we have mining. So it's a version of Bitcoin where we burn money to make blocks instead of burning energy. But then we don't do what Bitcoin does. Bitcoin burns energy and it gives all of the money to the burner. We say, no, you're going to burn money to make the block, and then we're going to burn energy to unleash the payment. And the result of this is that if you don't like who got paid, well, first of all, your multiple fork problem goes away, because you now, to get paid on 2 forks, you now need to hash on 2 forks. You can't hash on 2 forks and make money. So you can attack the network, but it's costing you money. And this goes back to the property of Bitcoin before the 51% attack, right? Like, well, I know Justin's son could reorg me, and maybe he has a bunch of miners, but the longer I wait, the more expensive it's going to be for him to attack. So if you need more security, you wait for more confirmations. That's the property in Bitcoin that goes away 50%. You've burned the money. You need to hash on multiple forks. There's something else. It's that if you are putting your own money into the block because you're attacking, you're putting your own money into a lottery game that has my money in it, right? Because for this to be profitable for you, you could just burn your own money. Okay, you put money in a block, you spend your own money to burn, and you get your money back. It's provably costly because there's no profit for you. You've lost half your money, right? You're generating fake work, but your fake work is spending the same that normal work would spend. The blockchain cannot discriminate against you. You're paying a fee. But the attack vectors all involve you cheating by trying to create fake work, which involves making these transactions that have your own money. And what we solve by this game is we make it impossible for you to profit. Because let's say Edgar is your first top node. Edgar's going to get paid 66% of the time, and you're going to get paid 33% of the time. The wiki explains how the calculations are done. But like, if I send a 10 Sato fee, and that makes a block and it goes through Edgar, Edgar wins 66% of the time. He has 10 out of 15, you have 5 out of 15. So if you want to cheat, you can cheat by adding your own money. But you're now putting your own money into a block that has my transaction. You cannot make money by just spending your own money. In order for you to make money, other people's money needs to be in that block. And Sato forces you, the way the math works, you need to put so much of your own money in the block that you will not get it back. And that is a cost that we can impose in routing work because we have the cryptographic SIGs, and we can use those cryptographic SIGs to make sure Edgar gets paid 66% of the time. And you add your own money, you're going to lower that. You add your own money, you've got more claims of payment in the block. Now he's getting paid 66 or 65. You add more money, 60%. You add more money, he's only getting paid 50% of the time. In order for him to get paid only 50% of the time, you have to have half of the money in that block. So that's kind of the layman's sense of how the math works. What we're doing is we're switching from this third thing, mining or staking, where 51% is always profitable, and we're switching to a form of work where the work is derived directly from the fee. So if you want to attack the network, you've got to spend money. But spending money is not costless, because we've got this lottery that costs money that unlocks the payment. And the profitable way to play the game is be Edgar. You run these data services, you're in Fura, you run the Web3 servers that power Web3, that power applications. And then if you do that, I send you my fees. The same way in Bitcoin, if I use the Bitcoin.com wallet, I send my transactions to Bitcoin.com servers. The difference is those servers are the ones that are getting paid now. And for you to attack that, you've got to come with your own money, and we can statistically guarantee that you're going to lose money. How the math works, it's complicated for people because people are used to proof of work and proof of stake. They're used to, I do mining, I get a block, I get paid. And what we have here is if you do the work of collecting the fees, you can burn your money. And then we have a second game where we're unburning the money, and your chance of payment depends on how much of that money in the block is yours and how much comes from other people. And it also depends for other people. Are you first hop? Are you second hop? Are you third hop? And the deeper you are in the network, the more expensive it is to attack.
Right, so it's not necessarily a stake that you can lose, but you can lose whatever transaction fee you're putting in terms of that particular block. So you can.
But who's losing? What we're saying is a permissionless blockchain has to prioritize the people that pay the highest fee. What we're technically doing, the way the math works out, is if you are attacking the network and you're orphaning every block, you are going to be forced to pay a fee that is equal to or greater than the rest of the network combined. At this point, no permissionless network should discriminate against you. So, like it's like there's a deprogramming process, because people are like, they think that the attacker is an identity. And it's like, look, man, there's no identity of an attacker. An attacker is someone who orphans work. That's what it is in Bitcoin. An attacker as a node is anyone who pushes a block off the longest chain. That's how Bitcoin works. It punishes them, right? It's like, if you orphan another block, you've got to produce 2 blocks in the time the rest of the network produces 1. That's where the tax comes in. Bitcoin's saying, if you're going to orphan blocks, we're going to make it more expensive. And that's why people build on the longest chain. We're incentivizing honesty by penalizing work orphaning. It's exactly the same in routing work.
Yeah, I think we might need a third episode even, because we're running out of time, and we're still not getting to all the questions we had, at least not what I had. Ed and Kate,
do you understand how transactions get routed? I send to Edgar, Edgar sends to you. Routing work builds up in mempools. Eventually someone has enough, they produce a block.
Right.
And then we're going to play the payment game. But all of those transactions disappear from people's mempools. And now we're building up again. And there's another node. It hits it. It produces a block.
Yeah. I that part, but still the part where for me, not visually exactly where the point is. Okay, when I produce a block, all the fees are burned, and I will get back that in a secondary mechanism. That part is for me not 100%.
It's not a secondary mechanism. It's the same mechanism, right? That's like saying finding the hash and publishing the hash are 2 mechanisms in Bitcoin. It's what you got is when we produce a block, we burn the fees, and then people can play a game to get paid. And that's
that part of people playing the game. But we will have to go into that in the next episode. Ed and Kate, do you guys want to squeeze in a quick one that you want to address before we end this episode?
Yeah, I think I have a question, but do we still have time? Is it okay?
We have just a couple of minutes.
All right. Okay. Just a quick one. So I think, David, your team, you and your team are really working on your intrinsic value. So this is just for our listeners, especially those startups, because as you know, what people buy or what the developers, the reason why they build on something is the perceived value. How important is it for you to work on your perceived value, and how do you work on it?
I mean, we're building applications experimentally, and the stuff that people use, we put more effort into developing. So,
Mhm.
of all of the applications, there's a ton on Cyto. There's about 4 that are getting real organic usage. We're putting more effort into developing those. But our bootstrapping problem is the opposite of Bitcoin. With Bitcoin, you've got this mining budget, and that means the network's secure. And the mining budget's like a battery in an electric car that's going to go to zero. And the Bitcoin strategy is, we got a lot of security, we're buying security, we're going to subsidize you, come build on this really secure network. And so they pay for security, they don't pay for applications. Our security comes from the size of the fee. So in order to make the network hyper secure, we need to find a way to get fees up. And so building applications is our form of developing the network. And that's why we prioritize the applications that people are using. Third-party devs, people are coming in, people are building. Everyone who's building is like, they're well aware of the problems with proof of work and proof of stake, and that's why they're here. Knowledge of Cyto is not, well, we're not a well-known project, but that is changing.
So how,
Does that
and
answer your question?
a little bit, yeah, but how are you, like, are you convincing developers to build, or you're just stating your message into the over the net and then let the builders come into you?
Most people don't understand blockchain, and they don't understand the problems. Most people, most developers, they take for granted that proof of work and proof of stake is secure. And if they're not secure, well, everyone's agreed they're secure. And their time frame is, I want to pump out a token and get paid, or I want to build something like Uniswap that collects fees today, so I don't need to care. So most developers don't have a focus on, let's build utility. And I mean, that's why they're all going around complaining about, where's infrastructure? And you see it on Twitter. They're like, we need more applications, we need more infrastructure. And it's like, yeah, so why don't you pay the people that develop them out of consensus? But the fact that people are asking that question instead of saying, maybe we should pay for the stuff that we want devs to do. Our strategy for devs is, we're building the network that pays them if they run apps, and we're giving them open source software. So we launched something last week. We put ETH actually onto Cyto. So you can now use Ethereum inside the game. So you can play Settlers of Cyto. You can gamble ETH on it if you want. You can play poker with ETH, whatever. Someone can add another crypto, set up a server, and they can be the TRX server. They can be the Bitcoin server. They can be the Nano server. And they can now be playing poker with those other cryptos and participating in Cyto and getting paid. So that's our strategy. Our strategy is, like, fundamentally, it's, if you fix the incentives, you're changing who gets paid. And the people that get paid in Cyto are the devs like Edgar. Like, that's why I'm sending him my transactions. He's running a server. I can't send them to you guys. So it's a total flip, and we believe long-term it changes incentives. It does mean short-term, we're not playing kind of the BS games that other networks do, because having devs do this or do that, it's hype. It's not. It's like, how many AAA games has anyone played on a blockchain?
Okay.
Like, they keep announcing them, and they're all garbage because nobody wants to play them, because the game is just like, oh, I spend $100 on this NFT. Like, that's not fun. The games on Cyto, they're actually fun. Check out Twilight Struggle. Check out Settlers.
We do play chess earlier. We just tried it.
People
I don't
go
know.
for chess. They go for chess because it's a game they heard of, or they try poker, and then they're like, but why am I doing this on the blockchain, right? You can have a video call the same time you're playing chess. Twilight Struggle. Here I stand. Beautiful game. 6 players, multiplayer. The kind of applications that are coming are way beyond chess. But
Yeah.
someone could.
We will try. Yeah, we will try.
Yeah.
Thank you, David.
Thanks a lot, appreciate it, and we'll have to do another one soon again. But that's only so.
Do this.
Yeah.
Dig into the Consensus Wiki. Send me any questions by email, and this is an open invitation to your listeners too. We really want people to understand, and there's a lot of we don't really call it deprogramming, but there are a lot of things that people take for granted in proof of work and proof of stake that when you point them out to them, they're like, oh, okay, maybe that isn't quite true, right? But all of these things, they're told by proof of stake developers, right? Like, you need to have 51% of the stake to attack the network. A lot of people are like, oh, but we can slash attackers. They don't even realize that there's no way to slash a malicious majority in proof of stake. So devs will come out there and they'll say things like, oh, we're secure against 66%. And it's like, or they don't know about halting attacks or something. Like, it's a problem. But anyway,
Great.
thank you guys for listening
here.
and asking
Yeah.
me.
That's a great invitation. Thank you for that, David. Highly appreciate that. And we'll keep in touch, keep following the project, and hopefully talk to you soon again. Thanks, David. Appreciate it.
Take care.
And thanks, Ed. Okay, bye, guys.